Section 1. The unseen logic of chance. Have you ever looked at a sky full of clouds and seen a face? Or perhaps you have flipped a coin after a run of heads tails must be next. We often think of randomness as pure chaos, a wild and untamed force without any rules. It feels messy, unpredictable, and entirely without logic. But what if I told you that within this apparent chaos, there is a quiet and steady order? Chance has a hidden logic, a set of principles that, once understood, can help us make sense of the world in a much clearer way. This logic is not found in a single event, but in the collection of many. This idea might seem strange at first. How can something be both random and orderly? Imagine standing by a busy road. You cannot possibly predict the exact moment the next car will pass, nor its color, nor its speed. Each car is a single random event. But if you were to stand there all day, you would notice patterns. You would see that traffic is heavier in the morning, evening. Section 2. Defining the indefinable. What is randomness? In simple terms, an event is random if we cannot predict its outcome with certainty before it happens. Think of a single coin flip. As it spins in the air, there is no way for you to know for sure whether it will land on heads, tails. Both outcomes are equally possible. This unpredictability is the core of randomness. The same goes for rolling a single die. Any one of its 6 faces could turn up, and we have no way of knowing which one it will be on any given roll. It is this element of surprise, this lack of foreknowledge for a single instance, that defines what it means for something to be random. Consider the weather. A meteorologist can give you a forecast, say, a 60% chance of rain tomorrow. This does not mean it will rain for 60% of the day. It means that in past situations with identical atmospheric conditions, it rained 6 out of 10 times. We cannot know for certain if it will rain tomorrow, making the event random from our perspective. Section 3. The gambler's fallacy, seeing faces in the clouds. Section 3. The gambler's fallacy, seeing faces in the clouds. Our brains are wonderful machines, built to find patterns. It is a survival skill. Our ancestors needed to see the pattern of a predator hiding in the grass, or recognize the pattern of changing seasons. But this strength is also a weakness. We are so good at finding patterns that we often see them where they do not exist. This tendency has a name: apophenia. It is why we see faces in clouds, animals in burnt toast, or hear hidden messages when a record is played backwards. We crave meaning and order so much that our minds will invent it, even from pure noise. One of the most common examples of this is the gambler's fallacy. Imagine you are at a roulette table and the ball has landed on black 10 times in a row. A powerful feeling starts to build inside you, a near certainty that the next spin must be red. It feels like a matter of cosmic balance. The universe owes you a red. But this feeling, however strong, is wrong. The roulette wheel has no memory. It does not know that it has landed on black 10 times. The chance of it landing on red on the next spin is exactly the same as it was on every other spin. This mistake comes from a misunderstanding of how probability works. So, if long streaks can happen by chance and we cannot trust our gut feelings about what should happen next, how can we find any certainty at all? The answer lies in a beautiful and simple mathematical idea known as the law of large numbers. You do not need to know any equations to understand it. The law simply states that as you repeat a random event more and more times, the average of the results will get closer and closer to the expected value. In other words, the more you do something, the more predictable the overall outcome becomes. Let's go back to our trusty coin. If you flip it just 10 times, you might get 7 heads and 3 tails. That is a 70-30 split, which feels quite far from the expected 50-50. You might even get 10 heads in a row. It is unlikely but possible. In the short term, randomness is wild and spiky. The results can jump all over the place. But what if you had the patience to flip that same coin 10,000 times? As you continued flipping, the percentage of heads would slowly but surely drift closer and closer to 50%. After 10,000 flips, you would be astonished if the result was not very near 5,000 heads and 5,000 tails. This is the law in action. The chaos of the individual flips is smoothed out by the sheer volume of them. Given that our brains are so eager to find patterns, even false ones, How can we tell a meaningful trend from a random fluctuation? We do not need a supercomputer or a degree in statistics. We just need a few simple, practical tools to guide our thinking. These tools help us slow down, question our initial assumptions, and look at the situation more objectively. The first and most important tool is repeat the test. A single event or a small cluster is not enough to prove anything. A real pattern should be repeatable. Suppose you think a coin is biased toward heads. Flipping it 10 times and getting 7 heads isn't strong evidence. That could easily happen by chance. But flip it 500 times and get 350 heads. That's different. The more you repeat the experiment, the more confident you can be it's not just a random fluke. So ask, does the pattern persist over many trials? If it does, it's more likely real. If it vanishes with more data, it was probably noise. The second tool, compare results with a control group. Imagine a new teaching method appears to improve scores in one classroom. That control group gives you a baseline. If the new method classroom does significantly better than the control, you have strong evidence the method caused it. It seems like a paradox, but randomness can be a powerful force for creating order. We tend to think of order as something that must be designed, planned, and meticulously controlled. But some of the most stable and interesting patterns in our world emerge spontaneously from the combined actions of countless independent, random choices. There is no central planner, no single mind guiding the process. The order simply arises from the chaos, a phenomenon scientists often call emergence. Think back to the crowd leaving the football stadium. Every individual is making their own random decision about which way to go. Yet, from this chaos of individual movements, lanes spontaneously form. It just happens. The result is a highly efficient highway to food, created by many random encounters and simple rules. From dunes to galaxies, simple local rules plus innumerable random motions yield grand, stable patterns. It has a hidden logic, a quiet rhythm that becomes clear when we look at the big picture. Single events may be wild and unpredictable, but the collective behavior of many events is often stable and orderly. We can make plans that are robust enough to handle unexpected events. We can save for a rainy day. We can diversify our investments. We can test ideas on a small scale before committing fully. By understanding the hidden logic of randomness, you gain a new lens through which to view the world. If you found these ideas interesting, please like, subscribe, and follow along for more. Join the conversation and share your own examples of seeing order in chaos. The more we question, test, and learn together, the better we become at navigating the beautiful, unpredictable dance of chance.